Hey everyone, today we're going to learn part 2 of our precipitation reactions. Now, in writing equations for reactions in aqueous solutions, it's often useful to indicate whether the dissolved substances are present predominantly as ions or as molecules. So I have a couple definitions here, and I'm going to provide examples on the next slide. So I'm going to be flipping back and forth between these two slides. First, let's talk about a molecular equation. This shows the complete chemical formula of my reactants and products in their molecular form, which means this is the most common way that you see equations written. To give you an example, here is a molecular equation. Note that everything is in its compound form, or considered molecular form, and it just gives the state of matter. This probably looks familiar because most equations you are given in molecular equations. However, since in aqueous solutions things dissolve and break apart into their ions, aqueous solutions like to give complete ionic equations. This is where everything that's a strong electrolyte and soluble, such as strong acids, bases, and salts, are split apart into their ions. If you look at an ionic equation, again, you're going to see silver nitrate split into the two ions that it creates, silver with a +1 charge and nitrate. Then you're going to see the potassium chloride split into K +1, Cl -1. Then you're going to have our arrow, like a typical reaction, and then this one, you're going to see doesn't split. And the reason it doesn't split is because it's a solid, so it doesn't go into the two ions that it can create. And then you have potassium nitrate. Potassium splits into its ions and then nitrate into its ions. So we're just splitting anything into the ions that they produce. Then the last one is a net ionic equation. This includes only the ions or molecules directly involved in the reaction. And in order to get the net ionic equation, it's pretty simple. You cross out anything that does not change from the left side of the arrow in the equation to the right side of the arrow. The things that didn't change or were deleted are called spectator ions. They're kind of like a sporting event. They just watch, they don't actually participate. So if I go back to my examples, my net ionic equation is silver +1, including chlorine, -1 yields silver chloride. The way we got from here down to here is we crossed out anything that was the same on both sides. So my nitrates were the same on both sides. My potassium were the same on both sides. So that left behind my silver, my chloride, and my silver chloride. And that's how I got to my net ionic. So here are the written instructions of how to get net ionic equations. First, we need to have our balanced molecular equation. And you should have done this on your homework last night. We have made the products and classified whether they have a precipitate or not. Then we'll need to balance them. And we worked on balancing equations in the last chapter. Second, we want to dissociate or split apart any soluble strong electrolytes. So anything that's a weak or a non-electrolyte, we're not going to touch those. The other thing about that is they have to be soluble, which means solids and liquids don't split. We're only going to split apart anything that has AQ after it. And then third part, this is where most people make a mistake. Any subscript on that element that was placed there because we crossed our charges has to be taken and put out front as a coefficient. For example, MgCl2. This 2 does not belong on chlorine. The only reason it's down there is because magnesium's 2 plus charge got crossed down on it. So what happens is this 2 needs to be stuck out front, such as here, and chlorine gets a -1 charge. Now, if there is a coefficient already on the number, because we had to do that for a balanced chemical equation, we take that number and multiply it with the coefficient. So our second example, say that MgCl2 had a 2 as a coefficient for the entire molecule. This 2 goes to everything. So it goes to magnesium, so that's why I have 2 Mg2 plus. And it also has to go to the chlorine. Now this doesn't belong here, so what happens is this 2 times 2 gave me my 4 for my chloride. One thing to be careful of, and this is why I put it as a third example, is a lot of people might want to take this number and move it, but SO4, that is not on there because of a charge being crossed. So that stays there. It can't move. So this 4 stays here because it's a polyatomic. However, this Na, that 2 on Na, that's not a polyatomic. The reason there's a 2 there is because of my sulfate charge. So that had to be moved out front here. Now, if you're still struggling with what stays and what doesn't, I would highly suggest getting out your polyatomic chart that I gave you at the beginning of the year. If you have something like ClO4, this 4 has to stay because it was originally on a polyatomic. This 3 stays on nitrate. That's a common one you guys see. Carbonate is also a common one. The 3 stays on carbonate. Another common one that you guys might see is sulfate. That 4 stays. Phosphate is also another common one. That 4 stays. And then last one, ammonium. This 4 stays. So look for your polyatomics. Once you get your complete ionic equation, you can cross out anything that remains unchanged from the left versus the right side. Again, I've said this already, but what you cross out, they're called spectator ions because they don't participate in the event. Just like spectators at a basketball game, they're not actually playing basketball, they're just watching it. And then the net ionic equation is whatever is left over. So let's actually look at the example that we gave yesterday. When we did this yesterday, it says, will a precipitate form when magnesium nitrate and sodium hydroxide are mixed? So what we did was we made the products, magnesium hydroxide and sodium nitrate, and we saw that magnesium hydroxide is a solid, and this one is an aqueous solution. Now that you've done this, if there is a solid, we're allowed to make a net ionic equation. There has to be a solid. We need to first balance the chemical equation. So that's what you're going to have to do first on your paper. So in order to balance it, see, this should balance it, 1 magnesium. And then here I have 2 nitrogen, 6, 7, 8, 6, 7, 8 oxygen, and then my sodium's 2, So that's balanced. Once you get it balanced, we need to write the ionic equation. And we do this by splitting apart anything that is a strong electrolyte, and it has to say AQ. So my Mg, this is NO3 is a strong electrolyte because there's a metal, and it's AQ, so I can split it. So Mg, there's a 1 there, so I'm okay. Its ion is a 2 plus charge from that uncrossing. This gets added. Here's my NO3. Now this 2 doesn't typically go there. It came from my magnesium. So what happens is that 2 has to go out front. So 2 NO3 and this is nitrate. It's a -1 charge because of my 1 down here on magnesium. So I've split apart my first one. Next, I'm going to work on sodium hydroxide. Now, sodium hydroxide has this coefficient 2 here. So this 2 has to go to both sodium and it also goes to hydroxide. So I have 2 Na, and sodium has a +1 charge because it's in group 1. Plus, that 2 also goes to my OH. 2 OH, and if I uncross it, this should have a -1 charge. And then I get my arrow, yields. Now remember, you can only split apart aqueous solutions, and this is a solid, so I'm not allowed to split it. So I'm going to write it exactly as I see it right here. I have 1 magnesium hydroxide, plus this one is a strong electrolyte because here's my metal and it's aqueous, so I'm allowed to split this. So this 2, remember, goes to both of them. 2 Na, and it has a +1 charge because it's in group 1, plus 2 NO3, -1 charge. And now I have split everything. Then we have to get our net ionic. In order to get your net ionic, you cross out anything that is the same on both sides. So here I have 2 NO3s, so both of those can cross out. I have 2 NAs, so both those can cross out. Then you write out everything that you did not cross out to get your net. So Mg2 plus 2OH minus 1 yields MgOH2 as a solid. So that's how you finish that one out. So we gave these also yesterday when we did the lesson. You can only make ionic and net ionic for anything that has a solid. So down here where both mine are aqueous, this one cannot have an ionic or net ionic equation because it's not a precipitation reaction. Here, this one cannot have a net ionic and ionic for a precipitation reaction because it's not one. So we're going to focus and practice with these top 2 up here. So I've actually put them newly on this slide to give us a little bit more room to work. I'm going to do the first one with you, and then I'm going to have you try to do the second one. So here, the first thing you should automatically do is balance your equation. So to balance it, it should be 1, 1, 1 on the barium sulfate, and then 2 on the potassium chloride. Then you guys can go and write your ionic. So here, this one's aqueous. I'm allowed to split this. And the coefficient's 1, so I don't have to worry about that. Barium has a 2+ charge if you uncross it. Plus chlorine. Now chlorine, this 2 doesn't belong down here. That's not a polyatomic. So here, I'm going to put the 2 out front. And then chlorine has a -1 charge if you uncross it. Plus, if I'm looking at my next molecule, there's a 1 out front, so I don't have to worry about that. This 2 on potassium doesn't come there because it's a polyatomic. It came from the sulfate. So I have 2 potassiums, and that has a +1 charge. And then my sulfate. This 4 belongs there. So I can just write SO4, 2 negative if I uncross this charge. AQ yields. This one is a solid, so I'm not allowed to split this. So barium sulfate plus, now I'm looking at my potassium chloride. I have a 2 out front, so remember that has to go to both of them. I have 2 Ks, and they have a +1 charge, and then I have 2 chlorines that have a -1 charge. Then to write your net, you need to cross out what is the same on both sides. So this one's chlorine and this one's chlorine. I have 2 potassium and 2 potassium. So now what I'm left with, I'm going to rewrite, and that will get me my net. Hopefully this is making sense. If it's not, please make sure that you come up and ask. I'm going to have you guys try to pause this video and try to do this one yourself. And then you guys can unpause it and check your answer. Okay, let's go ahead and get started. So if you are having a little bit of trouble with this one, first, let's get this thing balanced. So the easiest thing to do here is to put a 3 here. That gives me 6 lithium. I'm going to put a 6 here, and then a 2 here, and a 1. So when you balance this, 1, 6, 2, and 3. And you can always double check yourself. 2 iron, 2 iron. We got 3 sulfur, 3 sulfur, 12 plus 18 oxygen. So here is 6 plus 18 oxygen, and then 6 lithium, 6 lithium. And then 6 hydrogen and 6 hydrogen. So it all works out with that being balanced. Then we can go ahead and write our ionic. Hopefully you guys saw that you can split this because it's soluble, because my metal. And this too does not belong on iron, so I have to throw it out front. Now iron has a 3 charge if you've uncrossed it, so iron's a 3 plus sulfur. Now this 3 came from iron, so that means that 3 has to be thrown out front for sulfur or sulfate. And that one has a 2 negative charge. Plus, I can split this one apart because it's aqueous. This 6 gets distributed to everything. 6 Li plus 1 plus 6 OH, and then OH has a negative 1 charge from our polyatomic chart, yields. This one is a solid, so I can't split it, so I write it exactly as I see it, and that includes the 2 stays there. 2 FeOH3 as a solid. Plus, this one's aqueous and there's a metal, so I am allowed to split it. So, this is where we're going to see a little bit of multiplication. This 2 does not belong on lithium because it came from the sulfate's charge. I need to take this times my 3 out front. That's what gives me my 6 lithium. So 2 times 3. And lithium has a plus 1 charge. And then I add this. This 4 belongs on sulfate because sulfate's SO4. So I don't have to move this out front. This stays put. So I have my SO4, but this 3 also goes to sulfate. So I have 3 SO4, and sulfate has a 2 negative charge if you uncross it. Once you've written this, you can write your net equation. And you do this by crossing out what's the same on both sides. So 3 sulfates, 6 lithium, 6 lithium. So if you're looking here, 2 irons plus 6 OH minus 1 yields, that's an aqueous, yields 2 FeOH3s that are solid. Now, most people would stop here, but this is where I did this example to show you this. My coefficients out front is 2 to 6 to 2. We can reduce these coefficients, and this correctly written should be Fe3 plus, if I take the 6 and reduce it, this should be 3 OH negative 1 yields, and if I reduce this 2, should just be FeOH3 as a solid. So this is the reduced form. That last one was a hard one, which is why I really wanted to work through it with you guys. If you're still struggling, I highly suggest that you come in for extra help, as I've always stated. And that's the end of today's lesson. Here are just the solubility guidelines again. And if you have any questions, please make sure that you guys come in and ask. Otherwise, I hope you have a great day.